In this video, we're going to be going over emphysema. And emphysema is where you have destruction of the alveolar walls and causing the alveoli to be larger. For example, here is the alveoli in the alveolar sacs. As the walls get destroyed, that alveolus becomes larger as it merges with the next alveolus. And so what you wind up with is a number of larger alveoli. Shown here is a normal lung, and here is an emphysemic lung. And you can see how it has lots of openings in here because the alveoli the walls are being destroyed. Let's take a look at some more of the details of emphysema. As I said, it's characterized by enlargement of the air sacs, or the alveoli, because of the destruction of their walls and with resulting loss of elasticity. This is really important because along the walls of the alveoli, you have elastic fibers. So whenever you're inhaling, alveoli expand. Then when you exhale, these elastic fibers help to spring back in order to push that air out. Well, with somebody who has emphysema, when you look at the breathing of that, they're having to force air out. So they have this to get that air out because they're losing elasticity. And they don't have as much gas exchange taking place because as you destroy the walls, you're decreasing surface area, which allows less oxygen to get in and carbon dioxide to get out. And typically, if they're not able to get all the air out, then as we talked about in class, they're going to trap that air inside, air trapping, and it builds up the CO2 levels. Also, you have bronchioles that lose their structural support, and they can collapse when the person goes to exhale, which makes it difficult to get air out. Remember, emphysema is an obstructive lung disorder. Also, in addition, it can have characteristics of a restrictive lung disorder. When you look at the destruction of the walls, what exactly is causing this? And this results from excessive release of protein digestive enzymes, and these come from alveolar macrophages, remember those dust cells in the alveoli, as well as neutrophils. Well, neutrophils and macrophages are helping to protect the lungs against things such as pollution and irritants such as cigarette smoke that come into the lungs. These macrophages and neutrophils release enzymes, and they can also phagocytose these substances to destroy them. Especially such as bacteria, when you have infections in the lungs, they work to protect the lungs. But what happens is they get overwhelmed by all of these irritants. There's lots of irritants, especially if a person is smoking cigarettes. It can cause excessive release of these enzymes, especially neutrophil elastase. And this can overwhelm a substance that's called alpha-1 antitrypsin and start to destroy the lung. And what is alpha-1 antitrypsin? Well, this is a protein that's produced by the liver, and it travels via the bloodstream to the alveoli, where it helps to protect against the enzymes from destroying your own lung tissue. As these neutrophils and macrophages are producing these enzymes, they don't start destroying your own lungs because of alpha-1 antitrypsins protecting it. But if you overwhelm those macrophages and neutrophils, they start producing way more enzymes than the alpha-1 antitrypsin can stop from degrading your lungs. You start to degrade lung tissue. Anytime you have a protein being produced, there's a chance of having genetic disorder. And in this case, if somebody has two bad genes for making alpha-1 antitrypsin, then they're deficient in alpha-1 antitrypsin. And since it takes two bad genes, we call it an autosomal recessive disorder. And this is where you can see an individual developing emphysema often in their early 40s and 50s, a lot earlier than you would expect somebody to develop emphysema, especially if they're smoking cigarettes. But they could be deficient in alpha-1 antitrypsin. You want to make sure you star that term, alpha-1 antitrypsin. Let's test our knowledge. Pause your video, select the term that makes a sentence correct. Here are the answers. This concludes the video, and let me know if you have any questions.